Ahead now and develop the concept of flow work. What is flow work? Flow work is the work required to push a mass into or out of a control volume. Basically, what we're getting at right now is quantifying the energy that mass carries with it as it crosses a boundary. Right, again, in a prior chapter, we talked about mostly doing first law analyses on closed systems. In this chapter, we're doing first law analyses on open systems. And if you remember, the difference between a closed system and an open system is that an open system allows mass to cross the boundary. And so the mass is carrying with it energy. Energy transfers in three ways: by heat, by work, and by mass. And at this point, we haven't really taken time to quantify the energy that mass carries. But before we get there, I need to explain the concept of flow work, which again is what we're doing now. So again, flow work is the amount of energy of the work required to push a mass into or out of a control volume. And it's necessary for this in order to maintain a continuous flow. So as water or a gas or a fluid is moving, it's causing a flow because there's a force pushing it across the boundary and another force pushing it out of the boundary, right? Let's say I have a pipe and I have water flowing in the pipe. The only reason why water is flowing is because there's a pressure at the, actually, you know what? I'll call this P1 and that P2. It means that there's a pressure pushing the water through the pipe. So the pressure at point 1 has to be greater than the pressure at point 2 in order for the water to flow. So that work that's requiring the water to flow is caused by the fact that, we'll call it flow work, that there's a force acting on the fluid over a certain distance. Now I can go ahead and equate that force to be pressure times area, right? Where now this area times the length is equal to the volume. So what I have now is a pressure acting on the fluid to make the fluid go, pushing the fluid. If I put this into specific terms, it's quantified as the pressure multiplied by the specific volume of the fluid. And again, this comes from the concept of a force pushing the fluid a certain distance. So if I equate the force as pressure times area, remember, pressure is force over area. So that means that force is pressure times area. I substitute that into here, I get pressure times area times distance. And the area times the distance that the fluid is moving is volume. So that's where this concept comes from. Now, this flow work is the same whether the fluid is pushed in or out of the control volume. Flow work is expressed in terms of properties. So for this reason, flow work can be viewed as a combination property, right? Pressure times specific volume. As a result, the flow energy can be considered as part of the energy of the flowing fluid. This greatly simplifies our energy analysis of control volumes. And here's how it practically comes into play. If I wanted to look at the total energy that a fluid possesses, of a non-flowing fluid, right? The energy that a non-flowing fluid has is going to be the internal energy. This is all in specific terms, plus the kinetic energy, plus the potential energy, right? So that would be U plus 1/2 V squared plus GZ. This is again for a non-flowing fluid. Now, kinetic energy. How does a non-flowing fluid have kinetic energy? Like if I have a cup of water and I'm walking with a cup of water, although the water is not flowing, it is moving because I'm moving the system. It has a kinetic energy. But what if the fluid is flowing, right? If it's flowing, it has to possess, again, a certain flow energy. So if I designate the energy carried by a flowing fluid as theta, it would be the same as the non-flowing fluid plus the flow work. So if I were to expand this, I get the internal energy plus the flow work plus the kinetic energy plus the potential energy. Now, if you recall, there's a combination property called enthalpy, which is internal energy plus pressure times specific volume. That is what this is. H plus KE plus PE. So this U plus P nu, this internal energy plus flow work, combines together to be enthalpy. So again, now the total energy of a flowing fluid is enthalpy plus kinetic plus potential. So by using the enthalpy instead of the internal energy to represent the energy of a flowing fluid, one does not need to be concerned about the flow work because the flow work is contained in the enthalpy term.